Today's lesson is going to deal with chemical equilibrium. Okay, so when we say equilibrium, what are we talking about? What are we talking about? So let me flip the screen. Let me see if y'all know what chemical equilibrium is. Think about it. If we are in balance, that's equilibrium, okay? If we're on the same level, that's equilibrium. But what happens if one is above the other? You get a topsy-turvy situation, right? But if we're at equilibrium, that means we can go back and forth and back. Kind of like that Aaliyah song. Now let me see you go back. Now let me see you come forward. Okay? So we got to have equilibrium. If we want chemical equilibrium in a chemical reaction process, we have to make sure that things are in alignment with each other. Yes, Isabella, I love what you just said. Isabella said products and reactants moving back and forth at the same rate. Exactly. Haley says reversible reactions. Yes, 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 yes. So when we have equilibrium, things are in sync and we're good to go. Okay? Now, here's the thing. When we talk about using chemistry and applying chemistry with that, how does that all work? Well, let me show you. Okay, let me show you. So here on your screen here, you'll notice that there are some chemical equilibrium. There's a reaction. It's a chemical equilibrium reaction. And how do we know? Well, I should have had a double arrow so that you guys could see that. So let me go ahead and add that in here, okay, so you guys can see that. So that would be like a double arrow. Now I know it's kind of like upside down. So let me write that a little bit better, okay? So with your chemical equilibrium process, you're simply saying, how can this reaction go forward and backwards at the same time? Okay? At the same time. At a chemical reaction, you have nitrogen reacting with hydrogen to form ammonia. That you guys need to keep in mind. That you're going to have your products on the top and your reactants on the bottom. And the coefficients that you see in front of each of these formulas will be considered the exponents, okay? The exponents. Here's the thing. If they give you all three of these numbers, A, B, and C, you can plug them in and find the K, which is the chemical equilibrium. Sometimes they may give you the chemical equilibrium and they'll give you, let's say, A and B, and you have to find C. And it's really not hard to do that. Matter of fact, all you're doing is plugging the numbers in and multiplying and dividing. That's it. So let me give you an example of how we can actually use this problem here to solve that particular part of the process. Okay? K, and I should put this here so that way you guys can know these are the products over your reactants. Okay? Now you're probably saying, well, which side is which? Your reactants are on the left side and your products, meaning the end result of what you get, are on the right side. So your reactants are on the left, your products are on the right. Okay? So if I were to use this formula and say set it up so that I'm finding my K, what you have to do, okay, you would say K equals NH3, because that's your product side, squared over N2, which is one of your reactants, and H2, which is the other reactant, raised to the power of 3. Okay? That would be your formula for finding K, your chemical equilibrium. Okay?
If you've enjoyed this video and you want to see more, join us Monday through Thursday, Eastern Standard Time, 12 noon, to learn more about how to do chemistry the easy way with Professor TK the Chemist. Join us on YouTube and TikTok.